Welcome to cosmic sedation, where the stars hum softly and dreams are woven from the whispers of the universe. Tonight, let's explore a fascinating question. What if Earth is a prison planet? As you settle in for your cosmic journey, don't forget to subscribe and like if you enjoyed this session. Where are you tuning in from tonight? And what time do you usually fall asleep? Let's hear from you in the comments. The universe awaits. Let's begin our tranquil voyage together. Every time a human leaves Earth's atmosphere, they experience an unexpected gravitational pull back toward the planet, as if Earth itself is gently urging its inhabitants to explore beyond its confines. This phenomenon is not just physical but psychological. Humans often report a profound connection to Earth as soon as they leave it. Yet, this tug is more than mere gravity. It's part of Earth's intrinsic design. The planet's magnetic field, averaging 0.5 Gauss at the surface, acts like a protective blanket, shielding us from cosmic radiation. This same force, while vital for life on Earth, subtly propels our curiosity beyond its borders. In space, without this protection, the human body would suffer severe radiation exposure within minutes. Yet this risk also drives exploration and innovation. Each astronaut returning to Earth feels a deep sense of relief upon re-entry, as if coming home after a long journey. The surface temperature of Earth averages about 14 degrees Celsius, remarkably comfortable for life. However, beneath the crust lies an inferno hotter than the sun's surface, reaching temperatures up to 6,000 degrees Celsius. This extreme contrast between warmth and heat within our planet is a paradoxical drive. While Earth's stable temperature supports life, its inner turmoil stirs restless ambition. The iron in your blood was forged in the heart of stars that died before our sun even existed. These cosmic elements are remnants of stellar explosions billions of years ago. This ancient material not only fuels your body, but also drives your desire to explore beyond Earth's boundaries. Earth's surface is 71% water, a vast blue expanse visible from space. Yet, in the vacuum of deep space, water exists primarily as ice or vapor, unless carefully contained and pressurized. The human thirst for exploration is in part a response to this liquid, life-sustaining medium that Earth provides so generously, but can only truly exist here. Imagine floating in the void without oxygen. Your body would suffocate within minutes. Yet each breath you take on Earth is a reminder of how precious and delicate our environment is. This balance between life-supporting conditions and the inhospitable vastness of space pushes us to seek new frontiers. Earth has experienced 5 major extinction events throughout its 4.54 billion-year history. The most recent, the Cretaceous-Paleogene event, wiped out the dinosaurs 66 million years ago. Each mass extinction has reshaped life on Earth, creating opportunities for new species to evolve and thrive. This cycle of destruction and renewal instills within us a drive to preserve our existence elsewhere. When human civilizations face existential threats, they often turn their gaze towards space as a potential refuge. The moon missions in the 1960s were not just about national pride, but also about ensuring humanity's survival should Earth become uninhabitable. The process by which Earth repels its life forms is subtle yet profound. Every day, humans push back against the limitations of their terrestrial home, be it through technological advancement or philosophical inquiry. The exploration of space is more than a scientific endeavor. It's an intrinsic response to our planet's constraints. As we continue to venture beyond Earth, we carry with us not just equipment and knowledge, but also the essence of what makes us human: our curiosity, resilience, and desire for understanding. This journey, though fraught with challenges, mirrors the very survival instincts that have driven life on Earth since its inception. At a distance of approximately 13.8 billion light-years from Earth, a black hole named NGC 1277 rotates at astonishing speeds. Yet here on our planet's surface, we remain blissfully unaware of its existence. The paradox lies not in the cosmos, but within Earth itself. Despite being frozen in the vast coldness of space, the core of our planet maintains temperatures hotter than the sun's surface, reaching up to 6,000 degrees Celsius. Imagine a sphere of molten iron and nickel swirling at the center of this familiar blue marble. This internal heat engine generates an astounding 650 terawatts of power continuously, equivalent to 65,000 large nuclear reactors operating non-stop. The pressure here is so immense that it bends time itself, yet we walk on Earth's crust without feeling its profound pull. This thin layer, where humanity resides, is as fragile as an eggshell compared to the planet's bulk. The temperature gradient within Earth's layers defies logic. While the core simmers at 6,000 degrees Celsius, just 60 kilometers beneath our feet, it has already cooled to less than 1,000 degrees. This thin crust, where life thrives, is a narrow band of habitability that has remained stable for millions of years. Each human lifetime on Earth's surface, in this vast cosmic context, is but a fleeting moment, yet we thrive within this narrow temperature band. Earth's core acts like a slow-burning candle, steadily radiating heat through convection currents in the mantle. This process takes millions of years, and it's only now that some of this ancient energy reaches the surface as volcanic activity or geothermal vents beneath oceans. These vents teem with life sustained by chemosynthesis rather than photosynthesis, a testament to the diverse ways life can flourish on our planet. Consider Earth's age. At 4.54 billion years old, it has existed far longer than humans have walked its surface. Yet this internal heat engine, which began billions of years ago, still powers volcanic eruptions and tectonic plate movements today. The energy that once heated a young Earth is now responsible for shaping the landscape we see from satellites orbiting high above. This enduring warmth challenges the notion of what it means to be alive in a universe so vast and indifferent. As we sleep under blankets in cozy homes insulated against the cold night air, our planet continues its quiet dance with time and temperature. The internal heat engine ensures that even as we dream, Earth remains warm enough to sustain life on its surface, a delicate balance amidst the cosmic chill. Each day, this warmth challenges the notion of what it means to be alive in a universe so vast and indifferent, reminding us of the paradoxical nature of existence itself. While the outer reaches of space are frigidly cold, reaching temperatures as low as -270 degrees Celsius near black holes. Earth's core defies these extremes, maintaining its fiery embrace. The heat from Earth's interior is not only a relic of its formation, but also a critical factor in sustaining life on this planet, ensuring that the surface remains hospitable for billions more years. In the vacuum of space, far removed from Earth's atmosphere and gravity, a prison ship drifts silently through the void. The airlock hisses shut behind the prisoners, sealing them off from their world. Outside, temperatures fluctuate wildly between -270 degrees Celsius and 100 degrees Celsius due to solar exposure. Yet inside, the artificial environment maintains an Earth-like warmth of 14 degrees Celsius. Sound cannot travel through this emptiness. Every word spoken within the confines of the ship is met with a silence that would be deafening were it not for the hum of machinery. This absence of sound can induce profound sensory deprivation, a condition humans evolved to avoid on our planet, where even the faintest rustle signals potential danger or opportunity. The brain, accustomed to constant auditory input, struggles in this void, leading prisoners to experience heightened awareness of their own breathing and heartbeat. The prisoners aboard float in their designated cells, experiencing an eerie stillness. Weightlessness is akin to floating in water, but with no resistance, just endless drifting. Paradoxically, while outside exists a realm of unimaginable vastness, where distances are measured not by miles, but light years, within this confined space, every movement seems amplified and significant. Each gesture, each shift in position becomes a deliberate act, starkly different from the fluidity of life on Earth. The prisoners may find themselves marking time with small tasks, their minds searching for patterns in the repetitive cycle. Artificial lights flicker on at regular intervals, mimicking Earth's day-night cycle, yet there is no natural transition between these periods. This lack of variation can lead to disorientation as the brain struggles with signals that do not align with its expectations for how time should pass or what constitutes a night and day. The prisoners may find themselves tracking the artificial hours by the shadows cast on their cell walls, their minds searching for patterns in the repetitive cycle. Water in this environment exists only in controlled quantities. Each cell contains a small, sealed compartment filled with 2 liters of water, serving both as a necessary resource and a reminder of life's fragile connection to Earth's blue surface. The prisoners' interactions with their personal water supply are limited, and they must ration it carefully, knowing that beyond these walls, there is no easy access to this essential substance. This scarcity can induce anxiety, amplifying the psychological impact of sensory deprivation. Unexpectedly, some prisoners have reported feeling a strange sense of claustrophobia when surrounded by such limited space, even though their cells are relatively spacious compared to Earth-bound prisons. As the ship continues its journey through space, the prisoners endure sensory isolation in a manner that mirrors the extreme conditions of deep space itself. They experience neither touch from solid ground nor the varied sensory inputs typical of Earth's diverse landscapes. This deprivation can lead to hallucinations and psychological disturbances as the brain searches for stimuli it has not evolved to ignore. In this environment, even the simplest task, reaching for a cup of water, becomes an act laden with significance. The prisoners' cells are equipped with small viewing ports that offer glimpses of distant stars and galaxies. These fleeting glances into the cosmos can evoke a sense of awe as they reveal the exact number of 1,400 visible stars per square degree of sky beyond the glass. This precise measurement serves as an eternal reminder of how fragile and finite life on Earth truly is. In this extreme environment, time itself becomes distorted. Hours stretch into what feels like days, and the prisoners may lose track of their own identities in the monotony. They are not just isolated from each other, but from any sense of connection to the world outside. The isolation can lead to a peculiar introspection, as each prisoner grapples with questions about existence, purpose, and survival. The ship's artificial gravity fluctuates subtly during maneuvers, causing prisoners to feel slight shifts in their weightlessness. These adjustments are part of the ship's navigational system, designed to keep it on course through deep space. The sensation is disorienting, as if the body is being gently nudged in different directions, yet unable to anchor itself to anything substantial. As days turn into weeks, the prisoners adapt to their new reality, finding small ways to occupy themselves within the confines of their cells. Some might engage in quiet exercises or meditation to cope with the sensory deprivation and isolation. Others may focus on maintaining a semblance of routine, writing letters that will never be sent, or crafting objects from limited materials. In this environment, the prisoners are not just drifting through space, but also through time, a concept made more tangible by their confinement within the ship. The journey itself is an extended metaphor for life's journey, where every action and inaction contributes to a unique narrative. Each prisoner's experience becomes a testament to human endurance and resilience in the face of extreme isolation. The sensation of weightlessness can lead prisoners to perceive their own bodies differently. Without gravity pressing down on them, they might feel lighter than air, as if they are floating freely within themselves. This altered perception can be disorienting, but also offers a rare opportunity for introspection, a chance to explore the inner workings of their minds and emotions in an environment stripped bare of external distractions. The prisoners' cells are equipped with small viewing ports that offer glimpses of distant stars and galaxies. These fleeting glances into the cosmos can evoke a sense of wonder or dread, as they remind inmates of their isolation from the world they once knew. The vastness beyond the glass is both beautiful and terrifying, an eternal reminder of how fragile and finite life on Earth truly is. In this extreme environment, time itself becomes distorted. Hours stretch into what? At an altitude of approximately 80 kilometers above Earth's surface, the air becomes so thin that it barely registers on scientific instruments. Here, atomic oscillations vibrate at frequencies invisible to human eyes, creating what some theorists describe as a boundary zone between dimensions. These oscillations are generated by the rapid movement of atoms in the upper atmosphere, which resonate with cosmic radiation from distant stars. The frequencies produced can reach up to several terahertz, far beyond what human hearing can detect. These vibrations create an invisible barrier that filters out particles and energies not native to our reality. This phenomenon is both a marvel of nature and an enigma. It suggests that Earth's protective shield extends far beyond its physical boundary into realms we cannot see or touch. The energy generated by these oscillations is immense, yet delicate, maintaining the balance between dimensions. Interestingly, this process mirrors the way cell membranes regulate what enters and exits living organisms on a cosmic scale. Within this zone, there are instances where these atomic oscillations create temporary rifts in space-time itself. These brief openings allow particles from other dimensions to interact with our own world for microseconds before collapsing back into their respective planes. This fleeting interaction is theorized by some as a refuge for escaped souls, a concept more aligned with folklore than hard science, but intriguing nonetheless. The idea that our reality might be permeable to others at such high altitudes challenges the notion of isolation we often associate with outer space. Specifically, these interactions occur when atoms oscillate at frequencies between 10 and 30 terahertz, creating a window through which particles from other dimensions can briefly enter ours. The Earth's magnetic field plays a crucial role in shaping these oscillations, guiding the flow of charged particles that interact with atoms in the upper atmosphere. This dynamic interplay creates a complex dance of energy exchanges, further reinforcing the idea of invisible barriers between dimensions. The strength and consistency of this interaction vary depending on solar activity and Earth's position within its orbit. Incredibly, this delicate balance exists at the edge of our breathable atmosphere, where conditions are hostile to human life. However, recent studies suggest that these interactions can also generate electromagnetic fields strong enough to influence weather patterns on Earth's surface, creating unpredictable storms or altering local magnetic anomalies. Scientists have observed that these atomic oscillations are not uniform across different altitudes. They fluctuate in intensity and frequency, creating a layered effect in the upper atmosphere. This variability suggests that the boundaries between our dimension and others may be more complex than initially thought, with some regions being more permeable than others. The idea that there could be areas where these barriers are thinner raises questions about the nature of space-time itself and how it might connect different realities. For instance, certain regions at altitudes above 100 kilometers exhibit significantly higher levels of cosmic ray activity, indicating a greater likelihood for dimensional crossover events. At an altitude where oxygen becomes scarce, temperatures can plummet to -80 degrees Celsius. Yet, despite these harsh conditions, life's essential elements, carbon and nitrogen, still swirl through this region of thin atmosphere. These molecules follow complex paths dictated by the atomic oscillations, sometimes venturing close enough to our reality to be detected. This creates a paradox. While Earth appears isolated in space, it remains connected through molecular exchanges with unseen dimensions. Theories suggest that these interactions might play a role in maintaining cosmic balance, preventing an overload of exotic particles from other dimensions. The idea that Earth acts as a buffer against the chaotic forces beyond its surface is both humbling and awe-inspiring. It implies that our planet has been serving this function for billions of years, long before humans evolved to ponder such questions. Additionally, some researchers propose that these interactions could also influence the formation of cosmic dust particles, potentially contributing to the early stages of planetary development in neighboring star systems. Furthermore, these atomic oscillations could explain some unexplained phenomena reported by astronauts and pilots flying at extreme altitudes. Reports of strange lights or fleeting shadows might be attributed to particles from other dimensions, briefly entering our reality through the temporary rifts created by these vibrations. This raises intriguing possibilities about what else might exist beyond the visible universe. The energy required to sustain these atomic oscillations is vast, yet it operates within a system where every atom works in perfect harmony with its neighbors. This delicate balance suggests a level of order that transcends human understanding. It's a reminder of how much we have yet to learn about the forces that govern our existence. As dawn breaks and light filters through Earth's atmosphere, these atomic oscillations continue their invisible work. They remain unnoticed by most, but for those who understand their significance, they offer a glimpse into the interconnectedness of all things. The upper reaches of our atmosphere are not merely a barrier to space. Instead, they are gateways to realms beyond our comprehension. Solar flares erupt from the sun's surface with an energy equivalent to 1 billion hydrogen bombs, propelling charged particles through space at speeds exceeding 3 million kilometers per hour. These bursts of electromagnetic radiation and high-energy particles can take anywhere between 8 minutes and several days to reach Earth, depending on their speed. When these solar storms interact with Earth's magnetosphere, they trigger geomagnetic disturbances that ripple across the planet's technological infrastructure. The effects are not confined to space, but manifest in our day-to-day lives through disruptions in satellite communications, GPS inaccuracies, and even malfunctions in power grids. This intricate relationship between cosmic events and terrestrial systems underscores how deeply connected we are with the universe beyond our atmosphere. Astronomers first noticed these disturbances during the Carrington event of 1859, when telegraph operators experienced electric shocks from their equipment and observed sparks flying from their machines. These disruptions were caused by a massive solar flare that ejected a coronal mass ejection directly toward Earth, showcasing how vulnerable our technological systems are to such cosmic phenomena. This event serves as a stark reminder of the potential impact these solar flares can have on modern society. Interestingly, early Chinese astronomers recorded similar observations in star catalogues as far back as 1859 BC, indicating that humans have long been indirectly affected by solar activity. The particles released during solar flares interact with Earth's magnetic field, creating auroras in high-latitude regions. These breathtaking displays of light result from the collision of charged particles with atoms and molecules in our atmosphere, primarily oxygen and nitrogen. The vibrant colors that appear in the sky, greens, reds, purples, are not just a spectacle, but also a testament to the complex interplay between solar activity and Earth's magnetic field. These lights can be seen by inhabitants near the poles, yet few consider that they are witnessing the aftermath of an event billions of miles away. Solar flares have been observed for centuries, though their true nature was not fully understood until modern times. Early observations in China highlight how ancient civilizations noted peculiarities in the behavior of compass needles during certain times of heightened solar activity. This observation hints at a deeper connection between Earth's magnetic field and cosmic events, one that scientists are still unraveling today. The intensity and frequency of these flares vary significantly over an 11-year cycle known as the solar cycle. During periods of high activity, termed solar maximum, Earth experiences more frequent geomagnetic storms compared to quieter phases. One particularly notable effect of solar flares is their influence on satellite operations. Satellites, which orbit at an average altitude of 300 kilometers, are especially susceptible to the high-energy particles emitted during these events. These particles can cause temporary malfunctions or even permanent damage if not properly shielded. For instance, communication satellites that facilitate global internet and television services have experienced outages following significant solar activity. This reliance on space-based technology highlights how interconnected we have become with systems vulnerable to cosmic phenomena. Another fascinating aspect of solar flare disturbances is their role in shaping Earth's upper atmosphere. The increased particle influx during these events can cause the ionosphere, a layer rich in electrically charged particles between about 60 and 1,000 kilometers above Earth's surface, to expand temporarily. This expansion can interfere with radio signals and lead to disruptions in long-range communication systems that depend on this layer for transmission. While such disturbances are usually short-lived, they serve as a reminder of the delicate balance maintained by our planet's atmospheric layers. Additionally, solar flares contribute to the formation of polar auroras, which are visible displays caused by interactions between charged particles and Earth's magnetic field near the poles. The colors observed during these phenomena, greens, reds, purples, are determined by the type of atoms involved. Oxygen emits green or red light depending on its altitude within the atmosphere, while nitrogen produces blue or purple hues. These displays not only captivate those who witness them, but also provide valuable insights into the dynamic processes occurring in our planet's magnetic environment and upper atmosphere. Despite their potential for disruption, solar flares offer invaluable opportunities to study space weather and improve predictive models. By understanding these events better, scientists can develop more accurate forecasts that help mitigate risks associated with geomagnetic storms. Such advancements are crucial for protecting critical infrastructure like power grids, satellite operations, and communication systems from the impacts of cosmic disturbances. This ongoing research contributes not only to our safety, but also deepens our appreciation for the intricate connections between Earth and the cosmos. The surface of Earth, a sphere with a diameter of about 12,742 kilometers, appears tranquil from space, its blue and green hues suggesting life's persistence. Yet, beneath this veneer lies a planet in constant flux, where matter is both created and destroyed at an atomic level. As the sun rises over the Pacific Ocean, it warms the surface to around 15 degrees Celsius, a comfortable temperature for many living organisms. However, this warmth is fleeting, as Earth's average internal heat flow is approximately 87 milliwatts per square meter, a fraction of what sustains its outward appearance. Earth's core, an inferno hotter than the surface of the sun, reaches temperatures up to 6,000 degrees Celsius. This molten interior contrasts sharply with the chill of deep space just beyond our atmosphere. Yet, it is not the core but the thin layer above that contains most living organisms. Life clings tenaciously to this narrow band between a blazing inferno and an absolute zero vacuum. The paradox lies in how life on Earth thrives within such a precarious balance, a testament to nature's resilience rather than its stability. The planet's magnetic field, averaging about half a Gauss at the surface, serves as an invisible shield against cosmic radiation. This force deflects harmful particles from solar winds and interstellar space, protecting the biosphere below. Without this protection, life would be impossible on Earth. Interestingly, Mars, with a much weaker magnetic field, lost most of its atmosphere long ago, rendering it inhospitable for current forms of life. The longevity of Earth's protective shield is tied to the dynamo effect driven by our planet's rotation and molten core. This ongoing process has kept the biosphere viable for billions of years. As time progresses, Earth will continue its slow transformation into a hollow prison void. In approximately 5 billion years, when the sun expands into a red giant, it will engulf Earth, stripping away any remaining atmosphere and water. The planet's surface temperature will skyrocket, leading to the evaporation of oceans and lakes. Life, as we know it, will cease to exist, leaving behind only remnants of its former glory in the form of fossilized remains and altered landscapes. This process mirrors the fate of countless planets across the universe that have experienced similar endings, a reminder of the transient nature of life on any given world. The extinction events that Earth has endured throughout its history provide a grim preview of what lies ahead. Each event marked by environmental shifts or asteroid impacts has drastically reduced biodiversity and reshaped ecosystems. The Cretaceous-Paleogene event, for instance, wiped out the dinosaurs but allowed mammals to flourish. These episodes underscore the fragility of life amidst planetary changes. As Earth approaches its final stages, it will shed these remnants into the cosmos, becoming a cold, barren void drifting through space, much like the countless dead worlds that have preceded it. In this future scenario, Earth's once living forms will be reduced to mere elements distributed across interstellar space. The iron in our blood will float freely among stars, while silicon from computer chips may become part of distant planetary cores. This dispersion represents a cosmic recycling process, where the building blocks of life and technology are repurposed across the universe. Once upon a time, long before the concept of Earth as we know it existed, there was only chaos, a swirling cloud of dust and gas known as the solar nebula. This vast cosmic soup stretched across millions of kilometers, containing the raw materials for what would become our solar system. The nebula's particles, no larger than grains of sand, danced in an intricate ballet governed by gravity. These collisions were minuscule on a human scale, but had profound implications. They set off a chain reaction that would eventually coalesce into planets like Earth. Imagine watching this process from the perspective of one of those tiny particles, witnessing the slow transformation of chaos into order. As the nebula condensed, it flattened into a disk rotating faster and faster around its center. At the heart of this spinning cloud, matter grew denser and hotter until nuclear fusion ignited. A star was born. Our sun's birth marked the beginning of a new chapter for nearby matter, which now orbited the newborn star in various shapes and sizes. Among these smaller bodies, one would eventually become Earth, taking millions of years to coalesce from the swirling cloud. The formation of Earth wasn't just about particles coming together, but also involved immense pressure and heat. As material accreted, it compressed under its own gravity, generating temperatures hotter than the sun's surface, up to 6,000 degrees Celsius at the core. This intense heat drives tectonic activity on our planet today, shaping landscapes through volcanic eruptions and earthquakes. Long before any form of life existed on Earth, it faced another kind of threat, its own creation story. During its early formation, Earth was bombarded by celestial bodies, each impact leaving its mark on the surface. These collisions not only shaped Earth's geography, but also delivered vital elements such as water and organic compounds necessary for life to emerge. It is estimated that during this period, an asteroid the size of Mount Everest struck Earth every few hundred years, reshaping landscapes and altering climates in ways we can still observe today. Despite its relatively modest size compared to gas giants like Jupiter, Earth possesses a surprisingly powerful magnetic field. This invisible shield deflects harmful cosmic radiation and plays a crucial role in protecting life on the planet's surface. Without this protective barrier, the relentless bombardment of charged particles from space could strip away our atmosphere over time, rendering Earth uninhabitable. The strength of Earth's magnetic field averages about 0.5 Gauss at its surface, which is enough to shield us from solar winds and cosmic rays. Earth's journey from dust to prison world is marked by countless events that have shaped its destiny. From the violent collisions during its formation to the emergence of life and eventual confinement for advanced beings, each chapter in this cosmic saga contributes uniquely to our planet's existence. This intricate history not only defines Earth, but also reflects the larger narrative of the universe itself. The surface temperature of Earth averages around 14 degrees Celsius, which might seem modest compared to other planets in our solar system. However, this comfortable warmth is a result of complex interactions between the planet's atmosphere, oceans, and land masses. The balance required for such conditions is finely tuned. Even slight variations could lead to vastly different outcomes, like Mars, too cold for liquid water, or Venus, far too hot. Earth has experienced 5 major extinction events in its history, with the most recent being the Cretaceous Bailey gene event 66 million years ago. These mass extinctions have wiped out vast numbers of species and dramatically altered ecosystems. Each event marks a turning point in Earth's biological evolution, reshaping life on our planet in profound ways. The iron in your blood was forged in stars that died before our sun even existed, a reminder of Earth's cosmic origins. Each atom within us tells a tale of stellar explosions and the slow dance of gravity across billions of years. This ancient process ensured that when conditions were right, planets like Earth could form, providing the raw materials for life. Earth's core temperature reaches up to 6,000 degrees Celsius, hotter than the surface of the sun. This extreme heat is generated by residual heat from Earth's formation and ongoing radioactive decay within its interior. The intense pressure at these depths prevents this heat from escaping easily, maintaining a constant source of energy that drives geological processes on our planet's surface. Gravity's influence around Earth is not uniform. It subtly varies depending on altitude and latitude, creating distinct zones where time behaves in peculiar ways. At the equator, objects fall more slowly than at the poles due to centrifugal force slightly weakening gravitational attraction there. This minute difference causes time to stretch, meaning that clocks near the equator tick fractionally slower than those at the poles. Additionally, the varying density of Earth's crust affects how gravity pulls on objects. A clock placed atop Mount Everest and another at sea level would keep slightly different times despite their proximity. This phenomenon, known as gravitational time dilation, was first predicted by Albert Einstein in his theory of relativity. It demonstrates that time is not constant, but bends under the weight of mass. In space, far from Earth's gravity well, time flows differently still. At a distance of about 150 million kilometers from Earth, which is roughly where Mars orbits, time moves at its natural pace relative to the observer's motion through space-time. However, close to a black hole or neutron star, gravity warps time so severely that it appears almost frozen near the event horizon, an effect known as gravitational time dilation. This phenomenon is not just theoretical, it has practical implications in our daily lives. For instance, GPS satellites must account for this effect to provide accurate positioning data back on Earth. Without these adjustments, navigational systems would be off by several meters per day. Closer to home, the gravity well of Earth itself subtly affects time experienced at different points on its surface. The difference is small but measurable, about 35 microseconds faster per day for someone living at sea level compared to someone at an elevation of 10 kilometers. This effect becomes more pronounced as we consider even larger distances from Earth's center, such as the altitude of geostationary satellites orbiting approximately 36,000 kilometers above the equator. At this height, time moves slightly faster by about a factor of 1 part in 10 to the power of 14 compared to ground level. This discrepancy underscores how our perception of time is influenced not only by personal experiences, but also by the gravitational landscape we inhabit. Understanding these minute variations in time can lead us to consider what might happen if Earth were somehow altered significantly, such as through an increase in mass or a shift in its rotation rate. If Earth's mass increased dramatically, the strength of gravity would grow correspondingly, potentially creating regions where time could slow down so much that moments stretch infinitely long or collapse entirely into singularities. Conversely, should Earth's rotation speed up, the centrifugal force at the equator might become strong enough to counteract gravitational attraction completely, leading to areas where time seems to stop altogether. These hypothetical scenarios reveal how delicate our planet's balance truly is and highlight the intricate relationship between mass, motion, and temporal flow. The warping of time around Earth provides a unique perspective on the universe's grand complexity. While we often take time for granted, its behavior near massive objects like Earth offers insights into fundamental aspects of physics. This phenomenon underscores how even minor shifts in gravitational fields can have profound effects on our understanding of reality. As we observe these temporal distortions, we are reminded that time is not a rigid backdrop against which events unfold, but rather a dynamic participant in the cosmic dance. The concept of time dilation also extends to the future and past of Earth itself. Billions of years ago, when the planet was forming from the solar nebula, gravitational forces were significantly different due to the distribution of mass within the nascent solar system. Similarly, billions of years into the future, as Earth cools and eventually becomes a cold, lifeless rock, its gravitational influence will diminish. These changes in gravity over time suggest that the very structure of space around Earth has been, and will continue to be, constantly reshaped by cosmic events beyond our immediate perception. From a distance of approximately 38.4 thousand kilometers, the Moon looms large in Earth's sky, offering a stark contrast to our planet's vibrant biosphere. Earth sustains diverse ecosystems, from bustling forests teeming with wildlife to vast oceans brimming with marine life. This intricate web of life thrives under the protective umbrella of Earth's magnetic field, which deflects harmful solar radiation and maintains stable conditions necessary for complex organisms to flourish. The contrast highlights how tenuous our planet's environment truly is. On Earth, temperatures are relatively moderate due to factors such as cloud cover and ocean currents that help regulate heat distribution. In stark opposition, the Moon's surface temperature can plummet to -173 degrees Celsius during lunar night and soar to +123 degrees Celsius when exposed to direct sunlight. This extreme variation underscores the precarious balance required for life. Yet Earth's oceans absorb and distribute heat over vast areas, moderating temperatures by up to 20 degrees Celsius in coastal regions compared to landlocked areas. Each breath you take on Earth contains oxygen once part of ancient plants now extinct or transformed into fossil fuels. In contrast, the Moon offers no such comfort for living organisms. The moon's lack of atmosphere means that without spacesuits, humans could not survive beyond a few minutes on its surface due to extreme temperature fluctuations and the absence of breathable air. On Earth, human lifespans are measured in decades, while geological processes shaping our planet occur over millions of years. Erosion slowly wears down mountains and carves out canyons, illustrating the vast time scales at play. By comparison, the moon remains largely unchanged for billions of years, a testament to its inert state. This difference underscores the dynamic nature of life on Earth. Life on Earth thrives in environments ranging from arid deserts to icy tundras, each supporting unique ecosystems adapted to their specific conditions. Meanwhile, the lunar surface lacks any form of biological activity due to the lack of a substantial atmosphere and the absence of liquid water necessary for plant life. This contrast highlights how finely tuned our planet must be to support life as we know it. The temperature variation on Earth between night and day is relatively mild compared to the extreme fluctuations experienced on the moon. Oceans help regulate temperatures on Earth by absorbing solar radiation during the day and releasing heat at night, ensuring a more stable climate for life to flourish. The moon, in contrast, experiences dramatic shifts in surface temperature as it rotates through periods of direct sunlight and shadow. This difference illustrates how critical environmental factors are for sustaining life. Earth's magnetic field plays a crucial role in protecting its inhabitants from harmful cosmic radiation, facilitating the development of complex ecosystems. In stark contrast, the moon lacks such protection, leaving its surface exposed to constant bombardment by solar particles and micrometeorites. This resilience of Earth's biosphere in the face of these threats stands in sharp relief against the lifelessness of the lunar landscape. The process of photosynthesis on Earth enables plants to convert sunlight into energy, supporting an intricate food web that sustains diverse species across the globe. On the moon, however, this essential biological function is impossible due to the lack of a substantial atmosphere and the absence of liquid water necessary for plant life. This stark contrast serves as a poignant reminder of how fragile yet resilient Earth's ecosystems truly are. The presence of water on Earth, covering approximately 71% of its surface, enables complex chemical reactions crucial for life. In contrast, no stable bodies of liquid exist on the moon due to its thin atmosphere and extreme temperature fluctuations. This difference highlights the critical role that liquid water plays in fostering life's development and sustenance. Standing at the edge of a tectonic plate, you might feel an almost imperceptible vibration beneath your feet, a subtle pulse that is Earth's heartbeat. This movement is not random. It follows ancient rhythms set in motion billions of years ago when our planet first formed from the solar nebula. The temperature here varies little, averaging around 14 degrees Celsius, a surprisingly comfortable range for human life. Yet this warmth contrasts sharply with the core's inferno, reaching up to 6,000 degrees Celsius, hotter than the surface of the sun. This gradient of heat is crucial for our planet's dynamic processes. The hum you might hear as you stand there is not just a sound. It's a vibration that travels through rock and soil, carrying the echoes of Earth's distant past. These vibrations are akin to the ripples in a pond after a stone has been thrown, but on a planetary scale. Each tremor carries with it the memory of volcanic eruptions, shifting continents, and even ancient meteor impacts. This continuous movement is what keeps our planet alive, driving its internal heat engine and shaping its surface over millennia. Unlike Mars, which lacks this dynamic activity, Earth's restless core ensures that life can thrive on its surface. Imagine standing at a point where two tectonic plates meet, known as a transform boundary. Here, the ground beneath you is constantly shifting, albeit slowly, about 4 centimeters per year, roughly the pace of fingernail growth. This movement generates friction and stress along fault lines, leading to occasional earthquakes that release stored energy in sudden bursts. The pressure within these faults can reach astonishing levels, comparable to the force exerted by 1 million elephants standing on a single square meter. Yet, this immense power is harnessed over vast timescales, allowing life to adapt and flourish. The iron in your blood was forged in stars that died before our sun even existed. This cosmic recycling process ensures that every atom within you has been part of countless celestial events throughout the universe's history. When you stand on a tectonic plate, you are not just connected to Earth. You are linked to the very structure of existence itself. The minerals and elements that make up your body were once scattered across the cosmos before being drawn into our solar system and eventually incorporated into this planet. This connection underscores the intimate relationship between cosmic events and life on Earth. While standing at the edge of a tectonic plate, you might notice small fissures or cracks in the ground, signs of ongoing geological activity. These features are evidence of the slow but relentless forces shaping our world. Over time, these movements can lead to dramatic changes, such as the formation of new mountain ranges or the opening of vast ocean basins. The process is so gradual that it's imperceptible to human senses, yet it has been occurring for billions of years and will continue long after we are gone. This enduring cycle highlights the resilience of Earth systems. The hum you feel beneath your feet is a reminder of the planet's immense age and its ongoing transformation. While standing on this tectonic plate, consider that the same forces shaping the land beneath you have also sculpted landscapes across the globe for billions of years. This movement ensures that Earth remains dynamic and capable of supporting life. As you stand there, you are part of a vast, ancient process, a fleeting moment in an unending cycle of creation and destruction. Deep beneath Earth's surface, instruments detect magnetic anomalies that suggest hidden chambers within its crust. These structures are not naturally occurring. Their geomagnetic fields indicate deliberate engineering on a scale far beyond human reach. The temperature in these deep regions can reach up to 6,000 degrees Celsius, hotter than the sun's surface, and yet some areas maintain conditions stable enough for containment. This controlled environment ensures whatever lies within can survive indefinitely, hinting at advanced thermal regulation systems. These anomalies form intricate patterns, indicating complex systems designed to isolate and protect what lies within. The pressure in these chambers is immense, far exceeding sea-level atmospheric pressure on Earth's surface. This extraordinary stability suggests a purposeful design aimed at maintaining specific environments for whatever is being held within. These variations might serve multiple purposes, from energy generation to containment of entities that require precise environmental conditions. The magnetic fields surrounding these structures vary in intensity and direction, suggesting the presence of advanced technologies or natural processes yet to be fully understood. The instruments pick up faint signals that could indicate communication systems, possibly signaling to an unknown audience, perhaps even extraterrestrial beings. These signals might serve as a beacon, alerting others to the existence of these hidden chambers. The existence of such structures prompts questions about Earth's history and its place in the cosmos. If these chambers indeed house ancient secrets or imprisoned entities, they could offer insights into the origins of life on our planet, perhaps even reveal civilizations long forgotten by time. The paradoxical coexistence of extreme heat and controlled environments within these deep regions challenges conventional scientific understanding. Returning to the initial phenomenon, we find that the gravitational pull felt by astronauts as they leave Earth's atmosphere might symbolize more than just a physical force. It could represent an unseen connection between humanity and its origins. This gentle tug back toward Earth suggests that our planet is not merely a home, but also a repository of ancient knowledge and possibly imprisoned entities. As researchers continue to explore these magnetic anomalies, they may uncover secrets hidden for billions of years, challenging our understanding of our place in the universe. The instruments used to detect these anomalies are highly sensitive, capable of measuring minute variations in Earth's magnetic field. These devices, often found in deep mines and boreholes, provide insights into the planet's internal structure. The data they gather could offer clues about the ancient processes that shaped Earth, from its formation billions of years ago to the present day. This ongoing exploration reveals a world far more complex than what meets the eye, hinting at mysteries yet to be unraveled. The instruments used to detect these anomalies are equipped with advanced algorithms that can filter out noise and isolate specific patterns in the magnetic field data. These tools allow scientists to pinpoint locations where the anomalies occur with remarkable precision, offering a clearer picture of Earth's internal architecture. By analyzing these patterns, researchers hope to uncover more about the ancient processes that shaped our planet. At depths exceeding 10 kilometers, these instruments encounter magnetic fields that are not only stronger, but also exhibit unusual patterns. These anomalies suggest the presence of massive structures or chambers within Earth's crust, possibly housing ancient entities or artifacts from a time long forgotten. The pressure at such depth is immense, equivalent to thousands of atmospheres, and yet life as we know it could still exist in these extreme environments, adapted to thrive under conditions that would be lethal for surface-dwelling organisms. In some cases, the pressure variations are so pronounced that they create localized zones where water remains liquid despite temperatures exceeding 100 degrees Celsius, a phenomenon not fully explained by current geothermal models. The temperature gradients within these deep chambers are also remarkable. While the outer crust cools gradually with depth, some regions experience sudden spikes or drops in temperature, creating microclimates that defy conventional geothermal models. These variations could indicate active geological processes, such as mantle plumes or hidden reservoirs of magma. The presence of water, even in liquid form at these depths, remains a possibility, offering potential habitats for extremophiles, organisms capable of surviving in the most extreme conditions. The scale of these discoveries is humbling. While we explore the vastness of space and dream of distant galaxies, Earth itself harbors secrets that challenge our understanding of life's origins and the planet's history. The magnetic anomalies detected deep within Earth could be remnants of ancient civilizations or natural phenomena that have yet to be fully explained. As researchers delve deeper into these mysteries, they may uncover not just scientific truths, but also philosophical questions about humanity's place in the universe. Returning once more to the initial phenomenon, we see astronauts experiencing not just a physical pull back. As you leave Earth's atmosphere one last time tonight, feel its gentle pull guiding you back toward dreams of home. The journey ends here for now, but before you drift off, know that you've been a part of this quiet exploration with us. Thank you for being here. If you enjoyed the trip, consider subscribing and liking. Sweetest of night skies to you, until we meet again in the cosmic dream.